Hello and welcome back to yet another new video of For Knowledge. So in this video we are going to discuss about valence bond theory. So basically it is a subtopic from the chapter coordination compound which is there in class 12. So what is this valence bond theory? So what type of questions you can expect from this valence bond theory? Like in exam there will be draw the structure of this compound and you will question paper will ask you what will be the structure of this compound or what will be the hybridization of this compound, what will be the color, whether it will be colored or colorless, what will be its magnetic nature, what will be its magnetic moment. So this type of questions you can expect from this part. So first we have to memorize one thing, that coordination number, hybridization and structure. Basically when coordination number is 4, there are two types of hybridization possible, that is sp3 and dsp2. When hybridization is sp3, the name of the structure will be tetrahedral, and when the hybridization will be dsp2, then the structure name will be square planar. So it was all about 4. Now when the coordination number is 6, there are two types of hybridization possible, that is outer D complex and inner D complex. The outer D complex is sp3d2 and the name of the structure is octahedral, and the inner D complex, that is d2sp3, and the name is same as previous one, that is also octahedral. So now moving on to the compound. First we will do FeCN6 3 minus. Okay, so how to solve this type of problems? So first you have to memorize the hybridization of Fe. So I have already written the hybridization of Fe is argon 4s2 3d6. Now what will be the hybridization of Fe3 3 minus? Simply you have to remove 3 electrons from this hybridization, that is 4s2 and 1 from d6. So it will be 3d5. Okay, so I am writing it will be 3d5. So now we have to fill up the electron in the D shell. So how it will get filled? It will get filled like this. Okay, I have done. It has Fe3 negative has the structure like this one. Okay, so now we have to see which type of ligand is present. Here CN, cyanide. Now we have to get a knowledge of this one. CN is a strong field ligand. So when strong field ligand is present in the compound, then what happens? Then pairing of electron occurs. Okay, so this electron will go here and this one will go here. Okay, so after going it will look like this. So pairing of electron is done. So how many CNs are present? 6. So it will fill up 6 shells. So I am filling it up. 1, 2, 2, 3, 4, 5, 6. I have filled 6 shells. So what is this hybridization? It's D2sp3. 2 shell of D, 1 shell of S and 3 shell of P. So the hybridization of this compound is D2sp3. I am writing here D2sp3. Okay. So now what does D2sp3 says? What is the structure name of D2sp3? Octahedral. So the structure of this compound will be octahedral. So I am writing here octahedral and hybridization is D2sp3. Now what will be its magnetic moment? Now how to calculate magnetic moment? Magnetic moment depends on number of lone pairs. Here one lone pair is present. You can see here only one lone pair is present and N represents number of lone pair. So the calculation will be like this: 1 into 1 plus 1. That is 1 plus 1 2 into 1, that is 2. So root 2. So the magnetic moment of this compound is root 2. Now what will be its magnetism? It is a paramagnetic compound. Why? Because one lone pair is present. So it's a paramagnetic. If no pair of electrons were present, then it will be diamagnetic. Okay. So if one or more than one lone pair is present, then it's a paramagnetic compound. Okay. I'm writing it's a paramagnetic compound. Now, whether it will be a colored compound or a colorless, obviously it will be a colored compound because lone pair is present. So, coloring of a compound, magnetism of a compound, all it depends on the presence of a lone pair. If lone pair is present, then it's a paramagnetic and colorful compound, and if no lone pair are present, then it will be a diamagnetic and colorless compound. So it will be a colored compound. So I'm writing yes. Okay. So this was all about FeCN6 3-. Okay. Now I am changing the ligand into a weak field ligand. Now I have explained you a strong field ligand. Now I will show you a weak field ligand, that is H2O. So now the structure will be Fe H2O whole 6 3 plus. Okay. So similarly, hybridization will be same, and Fe3 will be same 3d5, and this one will also be same. Now the question is whether there will be any pairing of electrons. No, there will be a no pairing of electron because weak field ligand is present. So you have to keep in mind one thing, that if strong field ligand is present, then pairing will take place, and if weak field ligand is present, then no pairing of electrons will take place. Okay, this is one of the most important things in this valence bond theory. So I am doing here. I am using this part. I hope we have written it down. So no pairing of electron will take place. So 1, 2, 3, 4, 5. Now H2O 6. So you need 6 shells. So first 1, 2, 3, 4, 5, 6. So its hybridization is sp3d2. sp3d2. So hybridization is sp3d2. It's a outer D complex. Previous one was inner D complex, and this one is outer D complex. Structure name will be same, octahedral. Now magnetic moment. Here how many lone pairs are present? 5. So it will be 5 into 5 plus 1. That is 5 plus 1 6. 6 5s are 30. So root 30. Now magnetism. It will be a highly paramagnetic compound. Why? Because 5 lone pairs are present. And now what will be its color? It will be a colorful compound. So I am writing yes. It is a colored compound. So it was all about Fe H2O6 3 plus. Now I am moving on to a next compound, and now it will be CN4 2 minus. It was a 6 coordination number compound. Now I will show you a 4 coordination number compound. So the structure of NiCN4 2 minus. Now, what is the hybridization of this nickel? The hybridization of nickel is (3D8 4s2). The hybridization of nickel is 3D8 4s2. Now, what will be Ni2 minus? It will be Ar 3D8. Okay. Now, how it will look like? It will look like (3D8). So 1, 2, 3, 4, 5, 6, 7, 8. Okay. So this is the schematic diagram of Ni2 minus. So here a strong field ligand is present, that is Cn. So pairing of electron will take place. So this will go here. So pairing of electron will takes place and it will look like this. Okay, now CN4. So you need 4 shells. 1, 2, 3, 4. So what is its hybridization? It is DsP2. DsP2. Okay, so its hybridization is DsP2. So what will be its name? I've told you when it's DsP2, the name of the structure is square planar. The name of the structure is square planar. Now, what will be its magnetic moment? Now, what I have told you, magnetic moment depends on the number of lone pair present. Here, no lone pair are present, so magnetic moment will be 0 because n is 0. And now, whether it will be a colored compound? No, it is a colorless compound. Why? Because no lone pair are present. Similarly, it is also a diamagnetic compound because no lone pair are present. I hope now it's clear how to do NiCN for 2 minus. Now I'll show you a structure which is an exception, and you can expect this question in your exam because all this is simple structure. Okay, so exceptions and difficult questions you can expect in your exam. So the structure is CO NH3 whole 6 3 minus. Now what is so difficult about this question? It is a, you can see it's all like its previous type. What is its twist? The twist is what we know. NH3 is a weak field ligand, right? But here for this case, NH3 will act as a strong field ligand. Why? Because the presence of CO. The presence of CO makes this compound a strong field ligand. So you have to keep in mind, or you have to memorize that when this type of compounds come, when CO is present with NH3, then NH3 will act as a strong field ligand. Otherwise, in other case, for chromium, nickel, or any metal present with NH3, NH3 will act as a weak field ligand as general. But in case of CO, NH3 will act as a strong field ligand. So hybridization of cobalt is 3d7 4s2. Here it is 3 plus. So 3 or 3 plus. So it will be 3d6. So how it will look like? Three d six. So it will fill up 6 cells. 1, 2, 3, 4, 5, 6. So I already told you here NH3 will has a strong field ligand. So pairing of electron will take place. Okay. So how the structure will look like? So pairing of electron will take place. So I have paired the electrons. So here NH3 6. So you need 6 cells. So I am filling it up. 1, 2, 3, 4, 5, 6. So what will be this hybridization? Hybridization will be D2sp3. D2sp3. Okay. So its hybridization will be D2sp3, and the name of the structure will be octahedral, and what will be its magnetic moment? Similarly, no lone pair are present, so its magnetic moment will be 0. Similarly, it will be a colorless compound and it will be a diamagnetic compound because no lone pair are present. So I have shown you some structure. So I hope now it is clear. If in exam it comes, I hope you can do this. So I hope you have liked the video. So if you like the video, do comment, share and subscribe, and thank you.